Hello friends and welcome to average classes. Okay, so now we have come to our module 1 and chapter 3. We have studied the properties of fluid. Okay, we have completed our fluid statics. Now we have come to the chapter 3, that is fluid kinematics. Okay, ask your seniors or ask anyone who works in DRDO, ISRO, PARC or some prestigious organization, or who is doing PhD research and they are into something. They'll tell you the importance of fluid kinematics. They'll tell you how fluid kinematics is a tremendous tool you have for lot of practical applications. Okay, but when I was a student, I used to find it very hard because it involves mathematics. Okay, there are minor mathematics. There is not high level of mathematics is involved here. Okay, sir, but we are preparing for GATE, sir. Yes, if you are preparing for GATE, PSUs, AEE, Assistant Engineer, Assistant Executive Engineer, TSPSC, APPSC, UPSC, UPPSC, any state government public sector also you are preparing, you cannot just miss this. But sir, you tell that for everyone. Here numerical is compulsory from fluid kinematics. Compulsory. Okay, so we are gonna go slow and steady. Okay, there is lot to know, a lot to discuss in this particular topic. So we have divided this topic into some parts. Okay, for example, our part 1, we are going to discuss introduction and what are the applications. Okay, why we are studying this. I'll tell you why in this corona time it becomes even more more importance, I realized. Secondly, description of motion. See, the description of motion, normally people just say Lagrangian equation and Eulerian equation, what is what, one line sentence. No, we will study little detailing why, when you will use Lagrangian, when you are going to use Eulerian. Okay, because obviously after watching this video you need not to watch any other video. Okay, that's your average classes motto. Okay, so third is velocity and acceleration. Okay, we'll have one chapter of velocity acceleration. Then we'll come to types of flow. In these types of flow, out of all the flows, steady flow and unsteady flow, uniform flow and non-uniform flow, how acceleration is how acceleration we are defining in such cases, that we will be discussing. Then flow visualization, your streamline, streak line, path line, timeline, stream tube. Okay, those equations will be from flow visualization, will come to know. Next is your velocity potential function and stream function. Numericals will come from here. Numericals is going to come from your potential function and stream functions. Now, those who are studying engineering science, we are writing for engineering science, for them only Reynolds transport theorem we are going to study. For others, Reynolds transport theorem, exam point of view, not required. Okay, except for engineering sciences. Then we will be discussing numericals. Okay, so now without wasting much time, let's come to our chapter, fluid kinematics. So we have said, you have told there are two things. One is your statics. Okay, fluid motion, statics. So when I am talking statics, means something at rest. Something at rest. Then we will be studying kinetics. Sir, what is kinetic? Means whichever at motion. If they are under motion. Okay, we call it kinetics. This kinetics has two parts. One is kinematics, and one is your dynamics. Other one is your dynamics. Now can you visualize? This is your chapter 2. This is your chapter 3. This is your chapter 4. Module 1. Okay. Kinematics, we consider the motion of fluid without considering the forces. We do not consider the forces which cause the motion. Whereas in dynamics, we consider the forces which causes the motion. Understood? Kinematics and dynamics. Okay, sir. Now we are talking about kinematics. Okay. Sir, kinematics means the motion of fluid particle. The motion of fluid particle without referring to the forces causes the motion. See, by default it is at rest. So you need to apply some force. You need to apply some force or you need to give some moment. Then only the fluid will start flowing. Okay. But we are not discussing about the forces which cause the motion. Instead, we are considering what will be the velocity of the flow, what will be the acceleration of the flow, what is the pressure difference and why it is moving. Okay, these are the things we are going to consider and not the forces. What you are telling, sir? Without forces you are only considering. Why will I study this? I'll tell you. Let me tell you why. In India, Odisha, coastal Andhra, Tamil Nadu, West Bengal, this belt they are very prone to cyclone every year. Okay, almost every year cyclone will come. So you must be knowing before cyclone comes, they will accurately they'll tell you okay, what is the velocity of wind flowing and towards which direction it is flowing and how many days it will be staying at particular area, then it will pass. Now when the cyclone is coming, are you talking about the forces which cause the cyclone? Are you? No, right? Isn't? No. We are considered about the velocity, which direction it is going, at what speed the cyclone is coming, how many days it will take to pass this particular belt. Correct? So what happens when there is a cyclone? How the fluid kinematics helps here? See, there are water particles. Definitely there is a pressure difference. Sometimes there's just a low pressure is created in Bay of Bengal or Arabian Sea. Okay, so low pressure is created. So what actually happening is the fluid particles, okay, are moving with the air. That's why from satellite images I can see okay, there is a cyclone which is formed. But unless I know the velocity means what? Magnitude and direction. I cannot tell which way it is going. So what is rotational? Mainly what? So what is coming here? Fluid kinematics. So from that majority of your cyclone, hurricane, whatever comes now, that is irrotational only. Only the eye of the storm is rotational, which is continuously rotating. So these all things we are able to say with the help of fluid kinematics. Very, very important. Now ask a guy who is dealing with the satellite rockets. Okay, when the rocket is or the spacecraft is entering into the upper atmosphere, re-entering to the upper atmosphere, continuum, not valid, rarefield gas dynamics. Okay, again kinematics is helpful. Okay, now sir, which you say something regarding corona case? See, in corona case we have to maintain social distancing of 6 feet, like use mask. Okay, see what we are studying from here is, suppose someone has sneezed, so the particles, the fluid particle which is coming from your nose, okay, in that you have the virus. Okay, so how much distance the particles can travel? Each individual particle can maximum how much distance, which velocity, and at what place they will leave the energy and they will fall. So with this, what we can track is, we can track the contaminants. That's what we call fluid contaminants. Okay, how much distance the fluid contaminant can go, isn't it? From there we can come to a mathematical equation. If one person is got infected, how many other person it can infect with using the mask, without using the mask. Fluid kinematic. It's also known as the researcher's topic. Okay, see, I have done my research. I am a research scholar, so I am very, very thrilled whenever someone tells me about fluid kinematics and its implications in practical life. Humongous. Okay, I do agree. Fluid statics भी हम पढ़ रहे हैं, fluid hydraulic machines भी पढ़ रहे हैं, but fluid kinematics has its own path. Okay, sir. Okay, now coming back to the top. Now understood the applications. See your aviation sector. Okay, you have the velocity probes under the wing. Under the wing of an aeroplane, you have the velocity probe, which one can measure the this is the velocity. This is the particular velocity. This is also your fluid kinematics application. Aviation sector, spacecraft sector. Okay, your fluid hurricane, cyclone, all this weather reports, everything has been possible with the help of fluid kinematics. Okay, understood the applications? Very good. So coming to the definition, the branch of fluid mechanics which deals with the geometry of the motion, okay, without necessarily referring to the forces or moments that causes the motion. Because we are not taking the forces and moment causing the motion, and we are reading the geometry of the motion. What geometry of the motion? Hence, it's also the kinematics involves what? Your space and time coordinate. It's the motion of the fluid in terms of space and time coordinate. That means we'll be writing velocity as a function of what? X coordinate, y, z, t. Acceleration also will be a function of like. So this is what? Space and time coordinate. We are describing the geometry of the motion. Okay? That's it. This is your first class. This much is enough. Next class we are going to discuss the description of the motion, that is Eulerian and Lagrangian motion. Thanks for watching and all the very best.